So this is kind of an example of determining the noise impact. And an example is this kind of a contour of DML. So basically you take a mic, the measurement device, and you go around and measure the noise level over a long period of time, not maybe every hour or every 10 minutes or days or months. Then at each point, you will be able to calculate the DML and then draw the contour of the same DML. So you can expect as you get farther away from the airport, the DNL level will be smaller. So this outermost line in purple, that's the contour of DNL of 60. And this is kind of aligned with the runway direction because the airplanes operate this. So here, you're closer to the airport, but it's lower than 60. At this point, you are farther away from the airport, but your noise level is between 65 and 60. So this kind of a contour can be useful. Lines on a map defining the area around the airport that are estimated to be subjected to specific level of noise. And generally, it's drawn between 50 to 80 dBA. So this kind of a map can be very useful. So if you overlay, now on top of this, you draw a population, people's houses, and how many people are living here. You can instantly determine how many people are subject to how much level of noise. To determine how many people and properties are subject to noise of different levels. And determine which property qualifies for noise mitigation fund. So there must be a law that if you are living in an area where the noise is higher than a certain level, you're entitled for some compensation. And determine appropriate usage of certain area regarding new development. So when the real estate developers, they will try to just build shops and business anywhere possible. And as a regulator, government can check that area, and like if you're trying to build a school, they can say it's impossible, the noise level is above certain level. Generally, like schools, hospitals, religious institutions, and residences, they have a higher standard for the noise, and industrial and commercial, they have lower standard. So like, I don't know, maybe this area, they cannot build houses, but they can build factories or shopping centers. So this was a study. So because the noise is one of the difficulty is it's not just numbered, it's how people perceive them. And this study was the number of people who's highly annoyed. The number of people in an area that experience a noise level above a certain level. So here, they use DNL value of 65 decibel or higher. In 1978, only 15% of the people said it's too loud, I can't live here. However, more recent 2011 study says 25% of the people complained. So like everything's getting kind of quieter and quieter over time, and people's perception threshold against the noise, it's coming down and down. So that's another issue of the aircraft noise. Now, we kind of talked about the characteristics of the noise. So what airports can do, that's the point. I mean, airports cannot make a new engine or make new airplane. In terms of airports, what can be done? And the recommendation from ICAO is try to use balanced approach. I mean, obviously, we can reduce noise by reducing the noise at the source, which is kind of a quieter airplane. Another thing is land use planning and management, which is basically reducing the complaint. So not allowing people to live near the airport. And the third one is the one that we're mostly interested in. It's called noise abatement operational procedure. So how do you kind of operate the airplanes to minimize the noise impact? And the fourth case is the extreme case. If there's no other way, you just not allow the flight. So some airports around the world, they cannot take off and land within a certain time period, maybe from 11 p.m. to 5 a.m. Just no aircraft can operate out of that airport. It's the noise restriction. So the reduction at the source decreased the amount of noise being generated by the aircraft. Engine and airframe modification in response to the certification standards, airline customer requirements. For airport planners and operators, ensure compatibility with the airport structure. So airports cannot directly do this, but however, what airports can do is, we talked about the landing fee a couple of weeks before. So they can kind of pressure the airlines to switch to quieter airplane by making the fee structure such that like a big discount for quiet airplane, high penalty for a loud airplane. And then the airlines will calculate their balance sheet and they might switch to the quieter airplane. So there are actually a lot of operational procedures that impacts everything. So this chart, actually, all the procedures related to everything, noise, air quality, and climate change. I should remove this chart, there's too much information. And even I don't know in detail every single item of this, but it's just that there's many procedures that can help with the environmental issue on the climb phase, cruise phase, descent phase, and also on the surface and something else. So let's look at the airport procedures we can do. Okay, 9 minutes. So during the ground operation, taxiing with one engine turned off and extended towing and minimizing APU usage. So when the aircraft came down and touched down and land, it actually can, if it's multiple engine, turn off the other engine and use only one engine, has enough power to taxi, or use the tow truck as much as possible. And I think some research going on to replace this tow truck with an electric vehicle these days, and it can push around the airplane as much as possible. And also minimize the APU usage and use the ground supply power. When the airplane is parked at the gate, in the old days, the engine is not turned on. So to power the electronics and everything on the airplane, there is actually another generator. So if the airplane have two engines, when these main engines are turning, it will also generate electricity. However, if they are off, there's another one at the tail. And this one, it consumes fuel, and if you turn this engine on, it will generate only electricity. It will not generate any thrust. So that's called the APU, Auxiliary Power Unit. So instead of powering the airplane using the APU at the gate these days, they have a power plug and a very thick power line. So the airplane, like the crew comes in and actually plugs into the airplane and use the power supplied from the airport. That way, you can reduce the usage of APU and reduce the noise. And actually, most of these, they all basically try to minimize the engine usage, which will not only reduce the noise, but they will reduce any emission, and also it will help with climate change. On the ground, when the wind is not favorable, or if the runway is just short, they sometimes use this device called thrust reverser. And what it does is a part of the fan opens up and it deflects the fan exhaust to the front. And that slows down the airplane very quickly. And this generates a lot of noise. So there's a very strict regulation about the usage of the thrust reverser. Okay, so I guess the 60 frames per second setting was the problem. Yeah, I had it at full HD 60 frames per second, and that seems to have a 10-minute limit to prevent the overheating of the sensor. And the third case, ground run-up facilities with noise barriers, that's pretty intuitive. At some corner of the airport, there's ground run-up facilities for airplanes which gone through full maintenance. They'll have to test if the engine is working properly on the ground before it flies. So there, constructing a noise barrier here will definitely reduce the noise impact. One of the kind of a fundamental way of reducing the noise is making the ground operation efficient. So this is a famous picture about departure queue. So all these airplanes are waiting to take off at one runway. And if this happens, you might have to wait here for almost an hour. It's a very irritating situation. And because they are out of the gate, they cannot turn off their engine. They wait there with all of them with their engine on. So a good way to reduce everything is to prevent this kind of situation from happening. And that will require very efficient and intelligent management of the traffic on the surface. So what I'm also working on, and other countries they're working on, is solving this kind of a problem. And at least if you hold the airplanes at the gate instead of let it go, and then it can wait here with the engine off. And to estimate when would be the optimal time to depart from the gate, then it can taxi and come to the runway and just take off right away. So, I mean, usually for the passengers, you kind of have more peace of mind when you get on board the airplane. If you say the airplane is delayed 15 minutes at the gate, you have this fear of it's going to get delayed and delayed and delayed. However, I know it's kind of not the best for the passengers, but for the best of the systems, it's better to wait at the gate. And at least you can now use internet and do other things at the gate. Once the airplane pushes back from the gate, you depends on the policy, you may not be able to use your device, or you may not be able to charge your device, and it's not convenient to go to the restroom and all that. So we are trying to shift everything to the delay of the gate instead of the airplane kind of a delayed at the taxiway or the runway. I think if people get used to it, they will realize the benefit of staying at the gate. So there are a couple of procedures, specific procedures. This is departure procedure. So when the airplane takes off, there are two noise abatement departure procedures and ADP. The two are kind of opposite, and it's interesting. So the first noise abatement departure procedure, it reduces noise per area close to the end of the runway. So it delays acceleration to climb speed until 3,000 feet altitude. So this one is somehow, I don't know, maybe they bribed or they were community before they built the airport. If there's like houses very close to the runway, and they will really suffer. So this one, you take off with not your full power, as small power as possible to just take off. So with the low engine setting, you go fly by that area, and after that, you increase the power and climb. The second one, noise abatement departure procedure 2, is to reduce noise for areas farther from the runway. So in this case, the populated area is slightly away from the runway. In that case, what you want to do is go as high as possible, as fast as possible, to be kind of far away from that area quickly. So in this case, you actually go really full power. I mean, in normal case, the airplane might take off at maybe 85% power or 90% power. So here, you take off with maybe 60%. Here, you go with 100%. And then, once you are at certain altitude, before passing by that area, you back off. That's the second one. There's another one, is noise preferred runway assignment. Runways that sends aircraft over a sparsely populated area. So the famous example was that extra runway at the Boston airport. And there can be noise containment corridors. Departing and arriving flight tracks should be maintained. So even around the airport, they may specify a certain route that avoids the highly populated area and make airplanes only fly through that corridor to reduce the impact. Too bad we don't have sound. Oh, this was the problem. So this is Orange County Airport near LA. looked like it's a very famous airport for the Did you notice this? It suddenly becomes quieter, and it was climbing.